All right, in this video, we're going to line up more of these triple constructs with the three spatial dimensions, the linear spatial dimension, which is tied with magnetism, and the flat equatorial spatial dimension tied with the electric force, and then with the three-dimensional spherical force, which we've tied with, the weak force, but we're calling it the time force. We then unified those in together with the three quarks. And then what we said with gravity is really basically what we're saying is there are these three forces, electricity and magnetism. The old standard model focuses on it being electromagnetism as one force, but it's really two forces that just work together a lot. So you really have basically just these three forces. And then what gravity is these three forces up at a larger time size speed dimension. And what the strong force is going to be is these three forces down at a smaller time size speed dimension. And so we're just sort of lining up all these different sets of three, and we're going to continue with that here. But no theory of everything would be complete without really getting into the explanation of dark matter and dark energy. So in a previous video, we already talked about how in a human system, just through our whole human system, we have about 5% makes up our human brain, about 25% makes up our bone structure, and about 70% makes up our human body, and how that matches exactly with out through all of known existence. About 5% of what we see in nature is ordinary, or what I call bright matter, and then about 25% is dark matter, and then about 70% is dark energy. So it's pretty easy to put those things into our chart here. Magnetism ties in with the bone structure. And so it's the thing that, your bones are going to hold together and give you all this structure. That's coming from a lot of the magnetic force. Your brain is the engine of communications and movement and everything like that. And so that's primarily the electric force. And then the time force ties in with our body. So that's easy to put those into those categories. But what we really want to know here is, what are the particles? How we want a deeper explanation of what is dark matter and dark energy. Right now, like the standard model, basically they don't have any idea with dark matter or dark energy, but some of the leading theories are like that dark matter is made up of these things called WIMPs, weakly interacting massive particles. So that would be saying that the 5% of existence that we know of, which we see this incredible complexity of atoms, and then all of the different molecules, millions of different kinds of molecules that they form, and just the massive amount of complexity that we see making up all the structures and stuff within ordinary matter is all of this different stuff. And then it's like saying, but then this thing that makes up 5 times that much is just one weakly interacting particle or something. It doesn't make sense. It would make more sense if it was something that sort of fit in with all the chemistry and all the stuff that's going on in ordinary matter. And so to figure out what's going on with this, let's go back to, in the last video, we talked about how you have the 3 quarks and that the 2 up quarks are not the same. That you have the magnetic quark, which is tied to a linear spatial dimension. In the Earth, it's tying, it's centered on the North and South Pole, but it sort of goes through the 2 whole hemispheres as the 2 sides of the magnet. And then you have the thing that makes it all into a sphere as the time quark, which is the other up quark. And so then the electric quark, we said, is this bigger. It's more than double the size, the down quark, and that puts out this field of equatorial energy, which then the sun can grab onto the Earth with its equatorial field. The Earth can grab onto the moon with its large equatorial field. But the big thing that really ends up being the breakthrough explanation here, the possibility sets up the possibility for the explanation of dark matter and dark energy, is the simple question, well, if the two up quarks are two separate quarks, then does the electric quark have to be the large down quark? And I believe the explanation for dark matter and dark energy is no. No, it doesn't have to be. So look at this chart here, and dark matter is supposed to not interact with electric, so the reason we see the stars, that dark matter is sort of invisible, is because all the starlight can go right through all of the dark matter, so it does not interact with all of the bright matter energy that's traveling all over the place. If in dark matter you have a smaller time quark, the same as in our bright matter, but then you also have a smaller electric quark, and if the larger quark is the magnetic quark, if it becomes the double-sized big down quark, then that perfectly explains how our bones work, how our bone structure works. And it also fits with what we should see and what we do see with dark matter out there. And I'll get to the chemistry side of this in a second, but then what dark energy would be is it would have a smaller magnetic quark and a smaller electric quark. The thing that would be very large there would be the sphere. It would have a large spherical quark. And think of the cells in our human body, which are different than like the neurons and stuff in our brain. You have these large, and they're sort of roundish cells. I mean, they're squeezed in on all sides, but you have these large roundish cells with a small nucleus, and there is electrical and magnetic energy and everything down in the nucleus. And then you have the protoplasm with the organelles and stuff, and those could be explained. But so the dark energy with these large time sort of spheres fits very much with our body cells in our body. So it seems like a good explanation. If you look here on the chart, we know that all of the chemistry that we get with bright matter comes because of the electron and the valence shell structure of electrons, and how, for example, if you have an oxygen atom and it really wants to pick up 2 extra electrons and make it to the noble gas neon structure, where then it's sort of at rest. So all of our chemistry is driven through this action of the electron. And so dark matter might have a separate particle that I would call a magnetron that plays the role of an electron. And then dark energy might have what I would call a timatron. I spell it with a Y so it doesn't sound like timatron. But electrons themselves do have magnetic energy, and they have mass, not much, but a little bit of mass in there. So I don't know if there are separate magnetrons and timatrons. I think there probably would have to be, because if there were a bunch of electrons out there causing the chemistry of dark matter, those electrons would interfere with the starlight and everything. So I think you must have separate magnetrons and timatrons. But what this is saying is you would have an entire set of complex particles for both, dark matter and for dark energy, doing all the same kind of complex stuff, both that our bodies do and that bright matter does. I mean, you just have to figure there's got to be some kind of comparable. It's not just WIMPs or whatever. If we look at our bone cells and at how they connect with each other, that may give us some hints as to, down at the physics level, how the magnetron would behave, and look at our body cells and just the way they connect and interact. And that may give us some clues on how the timetrons may behave. So this should provide an explanation that we should be able to find some testable and verifiable stuff, and this should at least get us started, I think. But I'm pretty sure these are going to be the right particles, the basis type particles, that if the bright matter particle, the basic proton, is what we're looking at in the middle here, I think you're looking at a basic dark matter proton. It's a proton. But a dark matter proton and then a dark energy proton is going to be this larger spherical thing with, sort of smaller stuff inside of it. I wonder how a timetron, that's very interesting to start to think about how these particles could cause these things to interact and stuff. Next, in the DNA molecule, there's just another very clear three. You have the DNA molecule works in these series of codons of 3 nucleotide pairs, and then another 3 and another 3 and another 3. And when these form into genes, these codons end up making the amino acids made up of the 3 nucleotide pairs. So once again, this fits in perfectly with our model here. And it really, it gives you some interesting stuff to think about with, let's say you're looking at a whale, the structure of the way a whale is built compared to the structure of a way a giraffe is built. What you're really saying is each codon in the DNA, especially in these gene sections, and then each amino acid for the proteins it's simply giving it's giving a bone structure or magnetic communication for, at a small scale level, and then it's giving a brain or electric communication, or then it's giving a body or a time, a time energy communication. And so that's really telling us that the DNA molecule is simply taking these 3 forces of nature, again, applying them to our human system at a bantam or smaller level, and just using combinations of these 3s in through the DNA and then out into the proteins to just form the shapes and behaviors and actions and everything like that, all the way up, up and down through nature. There's something else that really ties in with this, both ties in with some of the dark, bright matter, dark energy stuff, and with the DNA, is the germ layers which form during gastrulation. And just let me side note here for a minute. So in the previous videos, we've already talked about how in another time, size, speed dimension, the human race is developing into a greater embryo, where at the 6 to 8 week mark, we humans are like greater glial cells. There's about 8 billion of us, just as there are about 8 billion glial cells, about the same number of computers, which are like greater neurons. The glial cells in humans remain separate and nurture the neurons or the computers. The computers and neurons all connect together into the neural network or into our internet. And at this time, when this has happened for the human race, and we start having all these screens we look at all the time and all the connection between all the computers, neurons and that stuff, the mother's electrical energy begins to flow down into the embryo and begins the default process. That's what started our whole default. And we already have videos on that. But what I'm saying is, so if that happens at the 6 to 8 week mark, which is where the human race is at right now, and we've already talked about how at about the 5 week mark, which was around the time of King Arthur and the legends of the Holy Grail, that's when the umbilical cord connected. And the umbilical cord started bringing in this extra energy. So after things staying so much the same through thousands and thousands of years of human history, all of a sudden, you have the Renaissance, the Enlightenment, the Industrial Revolution, the modern technological revolution. Our growth is just shot up exponentially. This is because of the umbilical cord connecting, and we're now on our way really growing into greater life. Well, gastrulation is a process that happens during the third and fourth weeks. This is where you sort of see the DNA at work and how it could form a giraffe or a whale or a human or something. Because things like, so you have these three germ cell layers. The ectoderm is really the innermost layer, and it's the one that eventually turns into the brain. And then you have the mesoderm, which turns into the bone structure. That's the middle layer in between these two. And on the outside, you have the endoderm, which is the time force, and it turns into the body. But for example, the muscles begin as part of the mesoderm. So the muscles are completely tied in with the magnetic force. Now, why would that be? Well, think of it. The muscles need to stay attached to the bones to work. The whole thing of the muscles is that they work and control the bones, but they do so where the bones don't really have any kind of time factor specifically. The muscles are all about timing. You walk at a certain pace, you move everything, the whole process of the muscles. And if you think about dark energy making up 70%, or a human body when you say a human body makes up 70%, the bone structure is about 25%, a lot of that human body comes from the muscles. So the muscles start out within the mesoderm, but then move out into the endoderm or the body. Another interesting thing, the brain comes out of the ectoderm, but so does the skin, our outermost self. Well, why is that? Because the whole entire thing that the skin does is sensory information, our five senses, that they're just filled with all kinds of ends of the axons, neurons and stuff, giving us all this information through sight, sound, smell, touch, all that sort of stuff. So you can sort of see how the DNA at a micro level is going to be changing all these things, these little force things, to cause these different kind of movements, and the way the proteins fold, different instructions through the codons and stuff that will create different bone structures and different things moving or acting in different ways. It's sort of really interesting. But so I don't really have the mesoderm, ectoderm, and endoderm in my chart, but they certainly fit with this concept, and I think are sort of instructive of some of the whole way. I mean, I think the whole process of building life is you're sort of braiding these different forces, these different forces of nature together in different ways, and that's what the DNA is able to do as it creates the proteins. The next thing I have on my chart is spin, and I just think the physicists focus on two kinds of spin: helical spin, which is just like if you take the planet Earth, it spins to the east. Any particle, the electric spin is this, your flat disk just has two ways that it can spin, to the right or the left, or to the east or west. Chiral spin is the time force spin. And I think it is, if you take an innermost sphere like the nuclear sphere and then the outermost sphere, are they spinning in the same direction, or are they spinning in opposite directions? And that has to do with your chiral spin. You can have diffusive spin, where energies are spinning up from the core, or coalescent spin, where your energies are spinning down from the core. But I think there has to be, you're not going to have electric and time spin and not have magnetic spin. And I'm going to prove this out later when I show this new logical system I've been developing. But magnetism, if we have a north-south pole for the magnetic force on the Earth, if you go down to another time-size speed level, that magnetism is going to flip by 90 degrees. And then if you go down another time-size speed level, it's going to flip another 90 degrees. And it continues to flip over like that. But I call this magnetic spin corporeal spin, and there's just going to be a lot more to look at with that. Then there continue to be a lot of things that can fit in with these three corridors tied in with these forces and spatial dimensions. There's a theory called CPT invariance theory, where charge conjugation fits with magnetism, parity fits with electricity, and time, of course, fits with the time force. The great mathematician Emmy Noether tied the symmetries of nature in with the conservation laws. So these things fit with our three corridors as well. I think she said the space symmetry, if the laws of physics are the same regardless of the location in the universe, then linear momentum is conserved. So that first one, space symmetry, would tie in, I think, be the one that would tie in with magnetism. Rotational symmetry, the focus on the spinning, like with parity or with the electric force. If the laws of physics remain the same, you rotate your experiment, whatever you're doing, if you rotate it through different orientations in space, then your angular momentum is conserved. And with the time symmetry, if the laws of physics don't change with time, then your energy is conserved. There's a lot to say about all of these different sorts of things, and I think there are plenty of other things that we could add in, but that's all we're going to say right here. But so basically, like I said earlier, you take electromagnetism, you break it into electricity and magnetism. You take the weak force, and really that becomes the time force that's going, it's going down through smaller and smaller levels, or up through larger and larger levels, whereas the electricity and magnetism are sort of focusing within. When you have a smaller sphere and a larger sphere, then the electricity and magnetism will play a role, kind of more of a gauge invariant role. But really, magnetism also has a lot to do with the going between these time, size, speed levels. But what magnetism does is it always has two things that balance against each other. So if you are looking at whatever the dynamics are between two spheres, either something squeezing down or something pushing up, you always divide it, take a square root or divide it by two, so that these two energies balance each other. And that ends up sort of holding a stable thing. The time force is running energies between a smaller sphere and a larger sphere, but it's doing it just as in a singular way. So it ends up controlling more of the dynamics going between larger and smaller levels. So the weak force with W minus particles maybe pushing down, or W plus particles coming up, neutrinos putting energies that will come up and then have a large effect on a larger level when they register occasionally and things like that. So then gravity, we say, is basically there are three types of gravity that are at another larger level. So, but there it's the same three forces again. And the strong force is these same three levels, same three forces again, down at a smaller time, size, speed level. But there's a lot to say about that. And there turns out to be a really fascinating tie-in between that and our American government, like the three branches of government and the two political parties and everything. So we're going to kind of anthropomorphize, really any of these three things, but we'll kind of focus on the three quarks and the strong force interactions. And so our third part, our next video, is going to really look mostly at the strong force, but mostly by looking at the American government and stuff like that. So we'll see you in the next video.